Today, we're going to be talking about climate change, which has become a very controversial topic. So, what I'm going to do today is really just kind of hit the foundations of climate change. And then in today's assignment, I'm going to hopefully show both sides of the argument and lead you towards making your own educated decisions about this topic. So, one thing that we do need to be sure about is that climates are constantly changing. But keep in mind the quote from last lesson: climate is your personality, weather is your mood. So, when we're talking about changes of climate, we're not talking about super crazy dramatic changes. We're talking about small changes. But those small changes to the climate, those small changes to your personality, are going to create huge mood swings, way bigger changes to the weather than what we would normally expect. So, yes, the climate changes are going to be subtle, but they're going to have dramatic effects. So we're going to start first by talking about a couple of naturally occurring climate cycles. So the Earth does go through natural cycles of different climates long before we were on this planet and probably long after we leave this planet. But we're starting with one that you've probably never said, "Ah, yes, that's an example of climate change," because that's how you talk when you think, right? "Oh, yes, absolutely." So, seasons are an example of climate change because if somebody said, "Hey, what's it like in North Carolina?" it kind of matters what time of the year they're talking about because it changes how much daylight we have, our temperature, what kind of weather to expect. So, all of those things are examples of changes of climate as we go through the year. Another one is ice ages. So the Earth has several different reasons why it goes through different ice ages. Sometimes the actual land masses are just located closer to the poles because our continents have been shifting for millions and millions of years. Another reason is sunspots, believe it or not. How many sunspots are on the sun in a given year can actually impact whether or not we have ice ages. So there's a lot of different reasons why, but they are naturally occurring cycles that the Earth goes through every 100,000 million years, something like that. Then there's El Nino and La Nina. Now, these are both ocean currents that happen off the coast of, off the coast of South America. If it's an unusually warm ocean current, it's an El Nino event. So if you look at the map on the left, you can find South America and see those oranges and yellows. That's showing that the temperatures in the water there are several degrees warmer than they are on average. So that's an El Nino year. If the ocean currents are unusually cold, then it's a La Nina year. So if you look at the picture on the right, you can see a side by side of the warmer El Nino and then the colder La Nina. Now, these happen on a pretty regular basis. They're happening roughly every 2 to 7 years, and they usually happen back to back with each other. So you'll have an El Nino year followed by a La Nina year. But the big thing is how they affect the entire planet. Now, with El Nino, it's easiest to think about it as it flip-flops the weather. So places that usually get pretty dry weather have a ton of rain, so they have a lot of flooding and mudslides and landslides. And then places that normally are tropical and get a lot of rain go through periods of drought, which can lead to things like brush fires, forest fires, things like that. One that I find super interesting, and I'm hoping we will find time this semester to cover volcanoes, is volcanic dust. Some of that dust is so light that it stays up in the atmosphere and it actually blocks the sun's radiation. Not just near where the volcano occurred, but actually it can spread out through Earth's wind systems and lower the entire planet's temperatures for several years. However, when people talk about climate change, they are usually focused on human-related climate change because humans are affecting the climate. If you look at the graph here, they're not discounting natural things. There are no people who believe in human-caused climate change that deny ice ages or volcanic eruptions. They know those things exist. They're saying, hey, those are natural cycles. What is happening with our climate, though, seems to just be going up. It doesn't seem to be a cycle. It just seems to be going up. And that data aligns with humans coming in and influencing the climate. Most of the time, when people talk about human-caused climate change, they focus on the greenhouse effect. Now, that is a natural thing that our planet does, where certain gases have the ability to hold on to the sun's radiation, particularly its heat, and trap it near Earth's surface. Now, that is actually a good thing. It helps Earth retain its heat. For instance, Mercury doesn't have the greenhouse effect. So during the daytime, it's crazy, crazy hot. But as soon as it turns and is facing away from the sun, it loses all of that heat. So it goes well below freezing. Our planet relatively has the same temperatures all day long, maybe a difference of like 20 or 30 degrees. If we didn't have the greenhouse effect, our temperatures would drop like to 400 below freezing, and we can't have life on Earth with that. So you're wondering, well, why do people talk about the greenhouse effect like it's bad? It's because we're taking a completely natural thing that the planet does, and we're adding too much to it. So let's say that you're sitting on your couch and you get cold, and so you put on a blanket, and you're comfortable. But then your mom sees you with a blanket and she goes, oh, poor thing, you must be cold. So she takes every blanket in your house and puts it on top of you. What she's done is she's added too many blankets, and now you're sitting underneath all those blankets sweating. Well, that's what the Earth is doing too. It is fine and natural to have that one blanket, but we're adding too many blankets to it. Now, the main greenhouse gas that people talk about is carbon dioxide. It is not the most potent greenhouse gas, but if you look at the pie chart there, it's the one that is causing the most changes to our environment because it's the one that is being added to the atmosphere at the highest rate. Now, there's a couple other greenhouse gases. There's methane, there's nitrous oxide. Believe it or not, water vapor has the ability to hold on to heat. And then ozone. Now, I put a star beside ozone because in last week's lessons, we learned that the ozone layer is an amazing thing to Earth's atmosphere. This ozone is not up in the stratosphere. This ozone is the man-made, human-caused ozone here in the troposphere. So just wanted to clarify there, this is human-caused ozone that is in our layer of the atmosphere, not the ozone layer at all. We're not worried about the ozone layer when we're talking about the greenhouse effect. Now, the main thing that adds carbon dioxide to the air is burning fossil fuels, and we already know that. So that can be things like burning it in order to produce electricity. It also counts as burning it in your vehicles, so motor vehicle exhaust as well. Now, not every single bit of carbon dioxide that we're putting out in the atmosphere stays in the atmosphere. Some of it's being absorbed by these things called carbon sinks. The biggest carbon sink on Earth is oceans. We talked about the difficulties of this in our saltwater unit. If you remember, we talked about ocean acidification, and it's because of the carbon dioxide being absorbed by the ocean. That's why it's being absorbed. It's a carbon sink. Other places are soil and plants. Trees are significantly better at it than like grass or flowers. So all of those things are soaking up carbon dioxide. That's a good thing, but we're still putting out too much for the carbon sinks to absorb. The last thing that I wanted to clarify before you move into the assignment today is global warming. Now, when global warming is talked about, they throw out data like, oh, we're increasing 2 to 3 degrees. And everybody's like, big whoop, the temperatures change like 20 degrees every day. Remember, Climate changes are small changes to the personality of a place. So I love this graph that I came across just a couple of months ago, actually. So y'all are the first ones to see it. As that shift moves just a little bit, you can see places that have hot weather are going to have more hot weather, and they're going to have record hot weather. Places that have cold weather are going to have less cold weather. So as everybody shifts, that little change in global temperatures, it's going to make huge differences to what type of weather those places get and what are the effects of those weathers.